Okay, so you can see here I've created a little image file to talk about 4.6 Venn diagrams in the traditional standpoint. What we have here is our A, our E, our I, and O. And this is basically the traditional square of opposition, but then what I have up here is our normal Venn diagrams, right? In which what this statement says is that all of the S's or P's, or namely all of the things in this region, are also part of this class, right? And the same thing here, that all of the no S or P is that anything in this class is separate from anything in this class. But down below we have the representation of the some S or P, and namely we've represented this by just putting an X in between there. But ultimately this doesn't tell us about determinately about either one, right? Whereas this case does, right? So you have the no S or P, we've put an X there to say that there is an S, but that it's not part of that class, right? So you can see here how the distribution patterns work, just to remind you about that, right? In this we say the S is distributed, here the S and the P are distributed, in this one neither S or P is distributed, and here we say that only the P is distributed because we learned that nothing is affected in there, right? And you can see how these are all the reverse, right? These are the contradictories, right? This is the contrary, the subcontrary, and these are the subalterns in which truth flows downward and falsity flows upward, right? But the question here is how are we to designate what we need is an existential marker, because strictly speaking, looking up here, there's no X there, so I can't actually conclude that some S or P. So you can see that our Venn diagram, our original Venn diagram, as indicated by these, let's see here, as is our traditional Venn diagram as indicated by these Venns here, right, do not actually inferentially relate to each other. So the E here conclusion doesn't look like the truth flows this way or the falsity flows this way. It's not quite representational. So our existential marker is essentially going to be this. This is an X with a circle around it, right? And so what I've done here is I've shown you how the Venn diagrams change. Because we have this existential marker, and we just place it into these upper universal statements. Such that what this is saying is that all of the S's are P, and we can, in fact, assume that there actually are such a things as S's. And likewise, no S or P, we could actually assume that there actually is such a thing as S's. So you can see now that we've added our existential marker, it does make sense, right, to say that if you say all S are P, you can in fact conclude that some S are P, right? Um, right? Or in other words, what we've done is we've shown that since there's an X in this region, there can also be an X in this, and there's also an X in this region. They're logically equivalent. So all we're doing is, if we're going to do Venn diagrams from the Aristotelian perspective, we have to also include this X, with this X with a circle in these universal statements. Otherwise, our Venn diagrams actually aren't going to work for us. That's basically what this chapter is about. Such that, let's see here if I can do this. It works, right? Let's create a Venn diagram. Let's take this sample argument. All A or B, therefore some A or B, right? So here's what it looks like to start with, right? Um, sorry, my computer's a little slow since I'm recording at the same time, right? So to say all A or B is essentially this statement there, right? So I've represented there where this region's the A's and here are the B's, right? And my conclusion is therefore some A or B, right? But remember, I have to include our existential marker. So let's just move that over right now, right, to represent this in the traditional perspective. It's very slow, right? Sorry about that. Let's kind of cut it out a little bit, right? But here I say all of the A's are B's, and look, there's actually an A. So then if I conclude, right, namely, and then our conclusion reads this, is that therefore some A or B, right? Which basically looks like this if I was to represent it, right? And then I have to also include a little X. So let's put an X, say place. Okay. So see, so this top one here, this was my premise, all A or B, and my conclusion was therefore some A or B. You can see here, because there's an X up here and there's an X there, they're actually related, and it actually is a valid argument. So by adding the existential marker, we can use Venn diagrams to test immediate inference statements. And if you take a look in your book on pages 228, 229, and 230, they give examples of this. And in your exercises for 4.6, essentially what you have to do is test and use these. So I hope this little graphic presentation has helped you to understand it in a way in which may not be readily apparent if you just read the lesson. Um, and also, there's plenty of paint programs you can use that it can help you do this. I'm using Paintbrush for Mac, which is a completely free program. I'm sure there are corollary programs for Windows. Okay, so I hope this helps you to some extent. I apologize for a little bit of the slowness of the computer. Okay, so I look forward to seeing you at the next lesson. If only I could see you. Okay, bye.